The radii of the small circles are equal to 3. The radius of the large circle is not given. We are going to find the area of the colored part. Draw the lines like this. Since all these lengths are equal to the radius, these triangles are equilateral triangles. So all these angles are 60 degrees, and this angle is 180 degrees. This is the central angle for these 2 points. Since it is 180 degrees, it means that the line connecting these 2 points passes through the center of the circle. The other 2 lines are also the same. They are the diameters of the respective circles. The length is 6. Therefore, this triangle is an equilateral triangle, and these parts are half of the identical circles. Now, we can come up with an idea to find the area of the colored part. It is the area of the large circle minus the 3 sectors, which are halves of the small circles, minus the area of this equilateral triangle. Moreover, we know the radii of the small circles and the side length of the equilateral triangle, but we don't know the radius of the large circle. The radius of the small circle is 3, so the area is 9 pi. To find the area of the equilateral triangle, we need to determine its height. Draw the perpendicular bisectors of each side. The intersection point is the circumcenter of the equilateral triangle. Each line passes through the opposite vertex, so this line corresponds to the height. Apply the Pythagorean theorem to this right triangle. The height is 3 root 3. Thus, the area of this equilateral triangle is this. Next, it's time to find the area of the large circle. We need to know its radius. Do you think this is the radius of the large circle? We can't be sure of that yet. It must be first confirmed. This point was the circumcenter of the equilateral triangle, where the perpendicular bisectors intersect. Look at these lines. They are all the radius of the small identical circles plus these segments. However, all these segments are equal. Why? In an equilateral triangle, the incenter, circumcenter, and centroid all coincide. Therefore, this point is also the centroid of this equilateral triangle. The centroid is the point where the 3 medians intersect and divides each median in a 2-to-1 ratio. Since this is an equilateral triangle, the lengths of the 3 medians are equal to 3 root 3. Therefore, the lengths of these segments are also equal to 1/3 of that, which is root 3. Since the lengths of these segments are equal, this point is the center of the large circle, and these lines are the radii of the large circle. The length is the sum of this length and this length, 3 plus root 3. Therefore, the area of the large circle is this. Finally, we have everything we need to find the area of the colored part. The area of the large circle minus 3 times half the area of the small circles minus the area of the equilateral triangle. It is the answer to this geometry problem.